let's start. Hi, I'm André Somers. I'm a software engineer at KDAB. Basically just like Mark. And I'm going to be talking about the two-way binding problem in QML. Okay, so I'll start with a short introduction of what the problem is, and I'll go over some non-solutions that we've seen or tried. We've either seen in customer code or we've tried ourselves and found out that it didn't end up working too well. Then I'll go over a couple of solutions that we found that actually do work in practice, and I'll bind it all together with some conclusions at the end. Yeah? Okay. So in a well-designed application, we basically have two things, right? We have a set of standard components that we want to reuse everywhere. We may even want to reuse them over multiple projects. And we have some kind of C++ set of controllers where our data lives, right? And then the actual QML application, your work, is to bind those two together in some sane way and lay them out, and so that all looks shiny and nice. Okay? So the QML part of the application really uses these components to build up the UI and then connect them to the controllers that actually contain the data. Yeah? And these controllers then provide the data and receive back the input that we have in the application. Make sense? Sure. So we have a controller in C++. We have a checkbox component that we wrote and that we want to be reusing. And then we have our main QML file that uses this checkbox and has a button to basically reset the controller state that's just simulating what might be happening somewhere else in the application. So what's the problem? So let me show the application here. Does that work? No. Fuck. It's always the same, right? Yeah. Okay. So we have our little main. We have our little. We're going to be focusing mainly on the QML file itself. So we have our application. So it uses our checkbox, and then our task is to hook up. We have some controller, which is a singleton in QML, and we have a property isBlue on there that we want to bind in two directions, right? So the checkbox should show the state, but if we check the checkbox, we should modify the state. Yeah? So how'd you do that? Anybody? No? Okay. Good guess. Something like that, right? And then on check changed, we want to say some controller that is blue is checked, right? Make sense? It's how you normally do that kind of thing, I guess, or want to do it. But what happens if we actually try this? Anyone wants to venture a guess? No, we don't have a binding loop here. We have a broken binding. Yep. Let's see if we can actually run it. So we have our application. This is our button. This is just simulating something that's happening in the back end, right? So we have our checkbox, and yeah, it goes to blue, right? And something in the background says, yeah, no, we go back to red. And you can see that this one responds, but our checkbox is not picking up the change, right? So that's a problem. That's the problem that we're going to be addressing here. Let me switch back to the presentation window. Yeah. Okay. So how do you design a good API for this, right? That we want to have components that both show a state and are able to manipulate that state. We want to have good API. We want to make sure that our data gets sent to the controller if we actually change something. And we preferably would not want to see this binding break. Okay. And it actually gets a little bit worse. Because in practice, we run into situations where our controller is really slow to respond. Maybe it needs to communicate over the network to some kind of server somewhere to see whether this value is actually allowed right now. or our backend might actually just plainly refuse the change for some reason, right? We've actually seen this in code. So how do you deal with that? Some non-solutions. So what does not work to solve this? Well, you could explicitly recreate the binding every time. So we start with just a function, isBlue binding, that just returns the state from the controller. And on check changed, we just set the new state and then we reinstate the binding, right? That works technically. It's just complete mess and it's unmaintainable, right? This breaks immediately as soon as you actually start to use this in any project of scale. So don't do that, please. Forget that you can create bindings at runtime, please. Yeah? This looks like a very smart trick. We could try to use aliases, right? Not have the value in our component at all. We just alias it in from outside, right? So we don't have a binding, so it can't break. Yeah, well, problem here is that you have a very bad API because you cannot see in the API what you're supposed to alias in. So that's a problem. So you'd have to rely on documentation or something like that for that, and that sucks. But the main problem with this is that it actually doesn't work with our controller that we want to be using. It doesn't work with singletons, and it doesn't work with context properties, which are the main mechanisms we use to expose C++ controllers. So basically, this one is a non-starter. Okay? It works in this kind of thing. If you have some controller with an ID, you can actually do this, and it works. But nah, don't use that either. You could take some inspiration from models, right? So instead of having a Boolean directly in your controller, you could make that an object that as a property, right? So Boolean value is an object, and that has getters and setters, and we can manipulate that. Basically like a mini Q abstract item model, but then with one value in there. Yeah, it works. You end up with something like this. Some controller is blue, is on, or something like that. Do we like this? It's a very heavy result, right? We get, for every property in our controller, we get additional objects. It's just very, very heavy. So you end up with Boolean value classes like this, and no, just no, okay? It's also completely not what you expect in QML applications. At least I don't expect this. So if you ever are tempted, don't go here. Yeah? So what can we do? Okay, we've got basically 3 approaches that sort of do work. And I'll go over them. We've actually used most of these in practice. The last way we haven't yet, but I will at one point, I guess. So what if we use an approach where instead of actually changing the value of the control directly, we just propose a new value to our user, right? So our component is not changing its own value, it's not changing its check state, it just has either another property or a signal like, okay, I propose to change my state to this value. And then the user of this checkbox says, well, on proposed checked, the proposed checked would be the name of the signal, right? Sets the new value on the controller, after which the controller can decide, okay, I'm going to accept this value or not. Sets that as its new value, after which this binding is still alive. Okay? This is an approach that actually works in practice. We've used this in a large-scale application. So this works. So we have a very simple property on the controller, not this huge binary, this huge class per property. You can bind as normal, right? As the place where we use it. our return connection, basically. So the return connection is the connection from the component back up to the controller. That's going to be using a different property or a signal than the main property itself. We use proposed normally for that. You can find your own keyword for that if you don't like proposed, but proposed this kind of carries the message, right? So let's demo that, maybe, really quickly. Do we have time for that? Yeah, I think so. Where's my stopwatch? Yeah, we check that. That should work. Okay. Back. So, oh, it wants to be configured, I guess. Yeah, sure. Oh, no, I need to configure it to, which one's 14? Second one down. Yeah, it's hard to read, and I don't have a copy here. So this one. Okay. So what does our QML look like now? Don't mind the height in the slide kind of comments. It's just for our own slide viewer that Mark just said you should never write yourself. Anyway, so how we're using it is now we have a checkbox, right? And we have checked is still on some controller is blue, and on proposed checked, some controller is blue is proposed checked. So we're setting the value that we get as a proposal, and then we rely on the controller to actually change its state and properly signal that. Yeah? And then on the checkbox, in this case, we're using a signal proposed checked, which we just emit from our mouse area that we just have over the whole checkbox, right? That's a very simple solution. This solution can be extended to work with, okay, how should we visualize the state where the backend has not yet accepted our change? For instance, if you have a very slow backend, you might want to have a representation of, okay, I've requested a change, but it's not there yet, right? We've done that in a large application where we use this as well. So you can actually see, yes, I press this button, you do have the feedback, we have requested this state, but if that value has not been accepted within a certain time period, we will revert back to our normal display state. Okay? So let's go back to this one. So benefits. It's a really simple approach in concept, right? So that's a big benefit for me because I like my code to be understandable by whoever reads it, which is good for maintainability and keeping costs down. It's flexible because we can extend it to work with in these scenarios where our backend is slow or simply refusing our changes. And it's lightweight. We don't need additional objects or anything like that. However, it only works on your own controls. This is different from what Qt's controls do, right? They don't have this kind of thing. So if you want to have consistency in your projects, you basically, well, either you don't have a consistency or you have only your own components, which may or may not be a problem. I don't know what project you're working on. It is somewhat easy to get wrong by accident, right? Because that property, that original property is still there, right? So you can get it wrong easily by trying to bind on that, and then your control doesn't work all of a sudden. And if you only find that out while your application is already installed at the user, you have a problem, right? Do proper testing. You'll find it. It's possible to have that handling, but the problem is that you have to replicate that handling of the and every control separately. So we try to make some kind of common component that we could reuse, but it's just tricky to make something that worked across the base. But if you don't have that problem, that you have a slow backend, that's not a big concern. So I would say in verdict, this is quite a good solution. This is workable. Yeah? So this is, I guess, solution one. Then we have the unbreakable binding approach. What if we could learn from what Qt itself is doing? Because if we carefully observe Qt behavior with Qt quick components, but also with text input, we see that if we make a binding like we made ourselves at the beginning, its binding actually does not break. Right? You would expect it to, but it doesn't. Maybe we can replicate that behavior. Yeah, we can. Turns out that we can. So how can we do that? Well, we have to do a little bit of work in our components. So we go back to using our checkbox like this, checked some controller is blue, and just say on check change some controller is blue is checked. So what we started out with. And we just bind as normal at the usage side, and it doesn't break. How do we do that? I will show you first that it really doesn't break. Because we just saw in our example that it did break. Where is my mouse? There. Nope, we want to have... Yeah, I'm using Qt 5.14 because it's way more convenient with singletons in QML, so I was lazy. Okay, so how do we do that? We have our main. So to show you that we're actually not cheating, right? Here is our checked on check change, some controller is blue, right? So we're back to what we wrote in our first attempt, which we saw breaking. But now let's try to run it. There it is. So we have it, make it blue, and make it red again, and we can see that it's actually still completely functional, right? Binding didn't break. How do we pull that off? Well, turns out that if we do a little bit of work on the component side, we can actually get around this behavior of breaking bindings. Because what we can do is that we can, instead of having that Boolean value property, right, that we had in the model approach on the controller side, we can use an object like that on the component side. And that's what we're doing here. So what we have in here is our Boolean value. We just call it internal. We don't have to do anything with it. And it just contains a Boolean value. And now our mouse area, we're using this instead of a normal Boolean. So we're having a property li is checked, is internal is on, right? So that's our internal property binding. So we're showing still checked on our API service of the component, but we have a new way of getting that. We're not using a normal property there. And in our mouse area, we use internal.toggle, where we can add properties on there. So Boolean value makes sense to have to just give the method toggle. Or we could use set on, right? That's just a callable or a slot on this thing. That works too. Thing what we cannot use is internal.isOn is not internal is on, right? That would be a property assignment, and then the whole thing would break again. Okay? But if we use this technique, it works. We do not have a breaking binding. Yay, win. Okay. Let's go back to the slides. So, do we like this? I do. It is quite robust. There is basically little or no usage-side code needed for this. It's really flexible in the way that we can set up our return connection, because we can do anything with the value. If you have that model approach, that it's really inflexible. And this is basically mimicking the behavior of most Qt components, which means consistency, which is good, right? However, it's a little bit confusing of how and why this works, I think. And we actually warn against situations like this in our training sometimes, because in theory, our binding and our whatever we're binding to can get out of sync here. And that is a really confusing situation to have. So that's a downside. But in general, pretty good. So I've got one last solution for you to show. How about we manage the sync between the properties ourselves, instead of relying on a Qt property binding for this? Then if we manage the sync, we don't have a binding, so the binding can't break. Make sense? Yeah. Okay, so how do we do that? We make a custom component to sync two other components, right? A value or a property on two others. And I just call that thing two-way binding, and I used a bit of syntactic sugar to make the on-checked possible, which is basically just a shorthand for assigning an object and a property name, right? That's just a public Qt API. There's no magic in there. So here we make a two-way binding on checked, which works on the parent, so on the checkbox itself, on the checked property, and we just bind it to some controller, which is our backend object, right? And our backend property is blue. Unfortunately, we have to use a string-based property name. I requested a feature for Qt to allow us to directly point to a property, but that's problematic because the syntax for that is really vague, how you should do that. So, but it would make these kind of things much nicer. But we've seen this kind of API on other Qt components like bindings and animations. They use the same kind of API, so it's not unheard of, right? It is kind of okay. So we have a very simple property again in our controller, or our controller and our component is also back to using a normal bool, right? So it's very simple again. But we now move the word. Go, yeah, works again, good, better. So our two-way binding is a custom component. I'm not going to dig into much detail because I think we're out of time, basically. So it's a separate element that keeps these two objects in sync. It's written in C++, and it's basically just using two signal slot connections, right? It's not rocket science to write one. And like I said, our property is just syntactic sugar. I think one big benefit of this one is that it's really explicit in what we do. Okay, we're explicitly stating we want to have a two-way binding in action here, and that's good. I don't know why it's not. I'll just discontinue talking. So there's no changes needed to our controls. It also works on Qt's native one. Hey. And it is extensible with policies, so you could extend this object with tricks like, okay, if the backend side doesn't update after a specific time, we just refer to, or we just go back to the original value, that kind of thing. And it's really hard to get wrong, and that's also important. You could combine this with the unbreakable binding approach if you want to be really safe. There is no support for things like expressions here yet. It would be possible to do that if we rely on some private API and a lot of work, but I've not come around to do that yet. So, in conclusion, well, what do you have? I think explicitly recreating the binding or aliasing in values or using that model-like approach, they're all worthless, right? Don't go there. But using either proposed value, an unbreakable binding, and or a two-way binding explicitly, that's a good approach to making real reusable objects, right? Really reusable components that you can use in your QML applications. I think that's it. If you have any questions left, I'm available. If there's no time here anymore, find me at the KDAB booth.